Okay, let's begin with question number 4. Let's move it to whiteboard, please. So we have a universal set there. It's defined as the values of x between -5 and 5. And then x is such that on the a is 8 is bigger than 2x plus 1, and the b, x squared is bigger than x plus 2. So they want to find the values of x for which they define the set a intersect b. That means they want to find the overlap of solutions, okay? Overlap of solutions which can satisfy satisfy both the conditions in A and B. Okay, so satisfy both A and B, the requirement within the world of the universal set is -5 to 5. That's what it means. Okay, now let's try to solve each part individually first. That means let's go for the A part. So you're talking about the set A. This one, the set A thing, let's put an arrow. So 8 is bigger than 2x plus 1 means 2x plus 1 is less than 8. So 2x is less than 7, or in other words, this is x is less than 3.5 when you have that 2. Okay, the second one, I want to talk about the set B. So please take note, this is x squared is bigger than x plus 2. So bring it to the left, x squared minus x minus 2 is bigger than 0. So the question arises whether this can be factorized or not. So we try and see, and it turns out that, oh yeah, actually can factorize. So when you factorize that, what we say in inequality, quadratic inequality like that, what you do is you write the roots here. So that means making this 2 0. Roots means making the factors 0. Or the other one is x plus 1 is 0. That means, in other words, x is -1 or 2 in order. Okay. Then what you need to do next is from these roots is that we need to draw something called a number line. Kind of like number line. Okay, let's do that, please. So that means this we have like this, ta-da, then like that, and this is like this. Okay, let's label it nicely. This so -1 is here. This is 2. What does this affect? So we need to follow accordingly. This one, so we imagine, because it's a positive, so we imagine the root is positive, like the box itself. You can't equal it, so put a circle like that. If you color like this, means it's only when if here was like can equal the boundary. So it doesn't equal that. It's a greater than, strictly greater than sign would indicate the circles. Likewise. Okay, so then the drawing looks a bit not so neat. Just repair that a little bit. Yep, better bit. Okay, now what we need to do is we need to consider the values for which along that line that factor or bracket will be positive for this range of x values respectively. So in this action where it is not marked, it's actually becoming negative. That's on the back. So until there any positive, then this is from that range onward is negative. That's what this factor diagram represents. Okay, and then what you do is vertically you multiply. So plus minus times minus is a plus, put in bracket overall. In this range, if x takes the range from -1 to 2, that means plus times minus, the overall product will be a minus. And the third range, x bigger than 2 to the right of 2 means the overall product there will be plus times plus, both terms plus. So it becomes a overall is also positive. Okay, these are the things like. Okay, now based on all this, we need the overall to be strictly positive. Bigger than 0 means it's positive. So it's either here or this part. Or so x is less than -1 or x is bigger than 2. So this is the solution for this part. And then we need to combine. So this is where the combined part comes in. So I'm just going to pull off the earlier and say in orange earlier, part 1. And I'm going to match it up with the universal set and blah, blah, blah. So we need to overlap or combine. Not really combine, overlap with x is less than 3.5. So how do we do this? And then we got the universal set somewhere, the corner there. So this is where the universal set also comes to play. Then I'm going to draw it here beside it maybe, so easy to see. Need more space like that. X is between 5 and that. Okay, now what we do is we create another number line. That number line is different. It's a factor. stricter version. This is just to see the combination so you can get a holistic solution. So we need to draw a few lines here, actually. Technically speaking, we need to draw for every single number here in order. So there will be 5 lines because there are 5 different numbers. 1, 2, 3, 4, 5. 2 blue numbers, 1 orange number, and 2 red numbers. So I'll try to mark them accordingly with the same color as well, if possible. So smallest of which is -5 in order, please. So the next one is -1. Then increasing likewise goes to 2. 2 is the same. Then the orange one is 3.5. Don't worry about that. Bigger than, less than, all signs. These are the bars, like. And then this is the red one is 5. Beyond 5. So the separation is based on these inequalities. Now let's try to match up all this, draw these inequalities on this line. So the blue one I'm going to draw first. X is less than -1 means, sorry, we start from the -5. Again, anything one else can. Okay, let's say I do like this. Ta-da, to the left like that. X bigger than 2 means from here to here. This is the overlapping with the orange. Please take note. That's what the intersection of the set A and B means. That means A and B. So I'm going to draw this one. Ta-da-da. This is less than, strictly like that. And then there's a limit. -5 to 5. It's an overall limit. So it's kind of like actually stopping them here. This one, no point, this part, because it's even lesser than that. So here I mark that limit. So that means based on all this, there are only two different answers, 2 different solutions. One is by overlapping it here. So the overlap I'm going to color now, so you can see that the orange and blue lines are where we're interested in the overlap for A and B. So the intersection of the set A and B will yield the answers. Let's put a nice box here and write them up. So X is between -5 to -1. So it cannot be in this side because here this is a cavern of blue. That's what it means. That means the blue line, which we have the color on it, the blue line and orange line share the same part here. Why this 5 down I didn't take, even though got color? Because the limit of that 5 to -5, the universal set, the red one, limits it there. Likewise, on this branch, we see the same thing from here and here. So the shade means like that. So it's the limit of the orange and the blue line overlap this thing. So it's all. So X is between 2 and 3.5. So these are the 2 answers. They are in intervals.